Hello and welcome to 8.3 Trigonometric Integrals Part 2. We start off with integral powers of tan x and secant x. So the main idea here when we encounter powers of tangent x and secant x is to use the identities for the tangent and the secant squared. So we have these two identities are the main identities we're going to use for tangent and secant. So the first thing we'll look at, example 5, integral of tangent to the fourth x. What we could do is split apart tangent to the fourth into tangent squared times tangent squared. Okay. Now, what that does is that allows us to write one of the two tangent squareds into the identity here, right? Because we know tangent squared is equal to secant squared minus 1. Okay, so let's do that. So we're going to write one of them as secant squared x minus 1. So I'll keep the first one. And then this one will be secant squared x minus 1 dx. Okay. And so now if we distribute the tangent squared, right, that'll give us tangent squared x secant squared x minus tangent squared x. Now it helps us for the tangent squared secant squared x, but we still have a little bit of work to do with the tangent squared x, which is okay. Okay, so because think about it, if you have tangent and you do derivative of tangent, you get secant squared. So the secant squared here is taking care of the chain rule effect for tangent. Okay, now we can't do the same thing with the tangent squared here, so what we'll need to do then is we'll do another rewriting of tangent squared as secant squared x minus 1. Okay, so let's do that real quick. So we have tangent squared x secant squared x minus, and then in place of tangent squared, let's put secant squared x minus 1. Okay. So we have tangent squared x secant squared x minus secant squared x. I'll distribute the minus sign here. And then distributing there will give us a plus 1. Okay, so we have integral. And now we're ready to integrate this, right? When we integrate tangent squared, we would get 1/3 of tangent cubed. So 1/3 tangent cubed x. And then integral of secant squared would be just regular tangent. So minus tangent x. And the integral of 1 would be x. And then plus a constant, of course. Okay. So that would be the final answer for example 5. Let's take a look at our next example. Integral of secant cubed x dx. Okay. So one thing we're going to do here, we're going to separate out secant cubed. Okay, we're going to say this is secant cubed will be equal to secant x times secant squared x dx. And we're going to attempt to solve this by integration by parts. So our u in this case will be secant x, and our dv will be secant squared x dx. Okay, so that means when we take the derivative of u, we get du would be secant tangent. And when we integrate secant squared to get the v, we get v equal to tangent x. Okay, so we got uv minus integral of v du. So that means we would have u v, so that's secant x tangent x. Let's put it this way: integral of secant cubed x dx equal secant x tangent x minus integral of v du. So tangent x times secant x tangent x dx. Okay, so we have the secant x tangent x minus, and then here we have integral, and this will be tangent squared x secant x dx. Okay, so now the tangent squared, we could rewrite that as secant squared minus 1. So secant squared x minus 1. Okay, and that means we have, if we have this and we pull the secant squared in here, we get integral of secant cubed x minus secant x dx. This, what we want to do is we could distribute the minus, but more importantly, all I want to do is separate out the integrals here. I'm going to show you guys this this technique we did earlier in the year. So we have minus integral of secant cubed x. Now if you do the minus of a minus, we have plus integral of secant x. So this one gets a dx, this one gets a dx. Now we still have the secant x tan x and we have the integral of secant cubed x dx. So this is what we're going to do, because it looks like we're kind of going to be running around in circles with the secant cubed x. So what we're going to do is add integral secant cubed x to both sides. Okay, so that'll give us 2 integral of secant cubed x dx is equal to secant x tan x plus integral of secant x So now if you guys remember integral of secant x dx from Calc 1, that was one of those special cases that you guys saw. Like we could multiply top and bottom for secant with an expression, and this one actually turns into ln. Right, so the integral of secant x would be ln of secant x plus tangent x Okay, and then once you have that, you can just divide both sides by 2 to get rid of this 2 that's in front, or you can multiply by 1/2, either way. So you can divide by 2, multiply by 1/2. Let's do multiply by 1/2. So we just end up with integral of secant cubed x dx is equal to 1/2 secant x tan x plus 1/2 ln of secant x plus tan x plus c. Okay, and that would be the final answer for that. Okay, let's take a look at our next example. Evaluate integral of tangent to the 4th x, secant to the 4th x dx. So here, what we could do is use one of our identities. We know that secant squared x is equal to 1 plus tangent squared x. Okay, so I have my tangent to the 4th x. I'm going to separate the secant to the 4th as secant squared x and a secant squared x. Now, one of the secant squared x's, I'm going to substitute with 1 plus tangent squared x. Okay, so my next line I have tangent to the 4th x, and then in place of secant squared, 1 plus tangent squared x, and I have my secant squared x dx. This outside secant squared x dx, that's going to act as my chain rule, right? As I take the derivative, let's take the derivative of tangent, I get secant squared. Okay, so let's distribute the tangent to the 4th into this parentheses. So I have tangent to the 4th x plus tangent, that would be to the 6th x, times secant squared x. Okay, and now let's, if you will, distribute the secant squared. So we basically have tangent to the 4th x secant squared x plus tangent to the 6th x secant squared x dx. Okay, so this is something we could easily integrate. Tangent to the 4th would be 1/5 tangent to the 5th x plus 1/7 tangent to the 7th x, and then don't forget the plus c. Okay. Sometimes you'll encounter integrals of this nature, where you have integral of sine and cosine, where the number in front of the x for the sine and the cosine, they are same numbers, different numbers, but like you could have a 2x with a 3x, or a 5x and a 3x, like things of those natures. So we have formulas for them. Right, so we have, if you have the m and n are the different coefficients, or it could be same coefficients, but you have m and n coefficients, we use these formulas. Okay, so, and you have the various types. You could have a sine with a sine, so you know what to do for that. You could use this formula. You could have a sine and a cosine, so then you can use the middle formula. And then you have integral of a cosine with a cosine, so then you use this formula. Okay, and all it is you replace, before you do any integrating, you replace the formula and then figure out the math involved, and then you do the integration from there. Okay, so let's take a look at an example of that. So in this next example, we're going to have a sine and a cosine. Okay, so we're going to be using the formula here for sine and cosine. Okay, so let's take a look at the problem. Integral of sine 3x cosine of 5x. Okay. So according to our formulas, the m, where we have sine of mx cosine of nx dx, our m is 3 and our cosine n is 5. Okay, so for that case, if we use the formula, we have 1/2, and this would be the sine of m minus n, sine of m minus n x, plus sine of m plus n x Okay, so in our case, what I could do is pull the 1/2 outside. Okay, and then I'll have sine. Now m minus n, so you have 3 minus 5. Okay, so you have negative 2x. Okay, and then we have m plus n for the second piece. So that would be sine of 3 plus 5, which is 8x. Okay, so we have that dx. Well, one thing we want to just make note, you might be for a moment thrown off by the sign of negative 2x. Just remember that we have sine as a property. We know that the sine of a negative x, that's the same as negative of the sine of x, right? So we could use that to our advantage here. Okay, so we could have 1/2 integral and just say negative sine of 2x plus sine of 8x. Okay, so now we could easily integrate this. We have 1/2, and then in here, integral of sine would be negative cosine, so we end up with negative, in this case this would be negative cosine of 2x, but we have to account for the 2x, so that would be negative 1/2 cosine of 2x. And then here we have actually that negative and the negative that was already there, we could cancel them out. And then for the integral of sine of 8x, that would be negative cosine of 8x, but then we're expecting an 8, so put a 1/8. Okay, and if we distribute the 1/4, the 1/2, we would get 1/4 cosine of 2x minus 1/16 cosine of 8x plus c. And that would be the final answer. Okay, any questions, just let me know, write me an email, we'll bring it up in class. Have a good day, have a good night, we'll see you soon.